Section 10.2 talks about regression. Regression gives definition of a regression. Given a collection of paired samples data, the regression equation y equal, you could think of it as mx plus b, where this is the y-intercept from algebra, and this is the slope. What a slope is, it's a rate of change. So, this rate of change is really what we're going to use to make predictions. I'll talk about that in a minute. Algebraically describes the relation between the two variables. It's a straight line. The graph of the regression equation is called the regression line, or the line of best fit. That's the term they use in most statistics books. Terminology. So, x is referred to as the explanatory variable, predictor variable, or the independent. Y is referred to as the response variable or the dependent variable. So this is independent and this is dependent on this. So regression line, least square line, line of best fit. Same thing. You're saying the same thing when you say those three lines or names. The line that minimizes the distance between the points and the line, it best fits the data points. Okay, what's going on with the writing today? And there's the equation where x bar, y bar will always be on the least square line. B1, which is the number in front of x, that's really the slope, and we said that's the average rate of change. And this is the y-intercept. That's basically what you start with. This is when x equals 0. And the formula runs like this. The y-intercept is r, our regression constant, times the standard deviation of the y's, which is the change in y, over the standard deviation of the x. Not to worry, the calculator will do all the work. You need to understand what this means. The y-intercept, this b0, is really the average of the y's minus this b1 times the average of the x's. Again, the calculator will give you everything. Let's get to an example and see how this works and applies. Round off. Round the slope and the y-intercept to 3 significant digits. Okay, no big deal. So, below is an example of 5 patients at a hospital with the information regarding their heights and weights. And they're talking about this problem. So they ask the first question. Describe the relationship of the data using scatter plot given. This is a scatter plot given. Well, do you see there's kind of so again, this is not the exact line, but a line kind of could fit through that. So we say this is linear. Now, 67, 155. This is x, this is y. Of course, green doesn't show a lot. Let me pick here. So, when we went up to 72, this went up to 220. When we went up to 77, this went up to 240. When we went down, this went down, and we went down. So it seems as one increase, the other increase. As one decrease, the other decrease. That's a positive relation, and it looks moderate to strong, depending on our last homework. Find the coefficient, find the correlation coefficient, test statistics, and determine whether a correlation exists. Well, let's see how this is going to work. We're going to input the data, so we're going to go to stat, I'm sorry, we're going to go to stat, edit. Okay, what just happened? Here we go. So we're going to clear this. How did you clear it? Let me clear that first. So this is how you clear it. You go up to the name, and you hit clear, and you hit enter, and it clears the whole row. So here we're going to input the first, which is 67, and they always give you those in order, so no need to worry about how that works. Just the first with the first, the second with the second, and the calculator is programmed in that direction, which is really good. So the last one is 69. Got it. Now let's go to the second. We have 155, 220 pounds, 240 pounds, 195, and 175. So the height is in inches. Each 12 inches is 1 foot. There it is. Now that the data is in there, we get out of it, and we hit, if you remember, variables. No, not variables. Stat, test, and remember, if we go backwards, it's the second one, that one. And L1, L2, everything's matching. Run down and get me what I need. And remember, we're going to scroll down just a bit. There it is. So let me copy that right here. So here we are. Let me shrink that a bit again. Let me put that right there. So here we are. So what do we notice? It's saying find the correlation coefficient. Correlation coefficient is right there. Test statistics. Test statistics. No biggie. I will take, remember this is -1, this is +1. And I'm going to look at that table. Let me get the table out. Okay, I got it. It's right there. So if I copy down n equal 5, okay, that is fine. Oh, okay, let me get rid of that. So I'm going to work with some of the technology. Okay, there it is. That's good enough. So we're going to take n equal 5. Alpha is 0.878 and -0.878. Remember, this indicates no correlation. This is positive strong correlation, negative strong correlation. So when we look at this, we notice R 0.9 falls in there. So there is a positive strong correlation, right? That is our conclusion. So our conclusion that it appears there is a linear correlation, right? There appears to be a positive, you know, say it positive. There appears to be linear correlation, or simply correlation will do. It doesn't matter. It's all good. All right. Find the line of best fit. Well, the line of best fit is right there. What's A? It's right there. plus b, there is b, 755x. There it is. That's pretty much the. Now comes the important part. Interpret the slope. There's the slope. The slope says for every, so every time you look at the slope, you put it over 1. For every 1 inch, let me write the letter 1. For every 1 inch increase in height, I would expect a 7.755 pounds increase in weight. That's what this sample pretty much predicts. Okay, interpretation of the slope. For every unit increase, they're talking about denominator. So remember, you could write any fraction over 1. In the e-value, on average, there is an increase or decrease depending whether it's positive or negative of the slope units in the RV. Interpretation of the Y-intercept. When the EV unit is 0, on average, the response variable is b sub 0. We already know how to do this. Here's another example. Recall the exercise from the last section, 10.1, in which we concluded there was a significant correlation between the average saturated fat consumption per day and the cholesterol level for 10 men. So N was 10, if you remember that. Now, find the regression equation where X is the average daily fat consumption. So this is L1, this is L2. And Y is the cholesterol level. Okay, well, let's do that. Now, I did input this. I input those data for you, the 55, the 180 to save time. And if you quit and you go to stat, again, we're going to go to the test and we're going to go for linear regression. Let's see what we get. L1, L2, as it is in that order. There it is. And we're going to scroll down a bit to get R. There it is. And let me copy this down. So this is all the information that we need. That's actually more than what we need. There's a bit more in there, but we really don't worry much about it. Okay, it's not more. Okay, it is more. Good. So here we have, find the regression equation. The regression equation is y equal, and they like to write it as b sub 0 plus b sub 1x, something like that. Well, there it is. B is, I'm sorry, A, they're A, 106.11, they're all to the nearest number, so we'll say 106 plus 1.59x. That's the equation. You could write it and you could say y equal 1.59x like we do in algebra, plus 1. That's normally how it's written. I'm just mimicking what the calculator says. So here, interpret the slope in the context of the problem. Well, the slope, this is over 1 for every 1 gram increase or consumption in fat, I would expect, since it's positive, expect a person's cholesterol level to increase by 1.59 milligram per centiliter. Predict, this is what we use these for. Predict the cholesterol level for a man whose consumption is 65 grams. If X equals 65 grams, what does Y equal? Y equal 106 plus 1.59 times 65. And that turns out to be, if you plug it in the calculator, 209.35 milligrams per centiliter. I would predict that a person who consumes 65 grams of fat to have a cholesterol level of 209.35 milligrams per centiliter. Now, this is if there's a regression. We know there is a regression. I mean correlation, if there is a correlation. Now, we want to predict if there is a significant linear, if there is a correlation, we use the regression line or the line of best fit to predict the values of Y given the specific X. However, if there is no correlation between X and Y, then the best predictor for Y is the mean of the Y's. For any value of X. If there's no correlation, we really don't even worry about using the regression line. We just worry about, you know what's the average of the Y's? We just do that. And let's get the last example out of the way. Here we are. And let's look at this problem. They're asking the first question, are fat and sodium content related in fast food? Here are the fat and sodium contents of several brands of burgers. They have them in. I'm going to input them in the calculator and I'll be right back. So, use alpha equal 0.05 significant level to determine if there is a correlation, linear correlation between those. If there's a correlation, I'm going to use the line. If there's no correlation, I'm going to use the average of the Y's. Remember, they always go in order. The average of the Y's. And the Y is listed on my L2. I'll show you really quick. Here's my calculator. I inputted L1 to be the first, which is the fat, and the second, and you always put them in order. So there it is. Now, if I quit and I go to my linear regression, L1, L2, very good. Calculate, there it is. Scroll down a bit. Let me copy that down. That has all the information that I need for this problem. Let me shrink that and move it a bit. There it is. So what is it they want? What's the null hypothesis? The null hypothesis will always say these have no correlation. Alternative will say, well, it appears there is. T, if you remember, that was r divided by the square root of 1 minus r squared divided by n minus 2. What is n in this case? 7. I always write n. So here we're looking at 0.199 divided by the square root of 1 minus 0.03962 divided by n minus 2, which is 5. I plug this in my calculator, I get 0.4541. We did this way too many times. Now, if I want the p-value, it's always two-sided. Alpha equal 5%, right? So the p-value is going to be 2 times the probability that t is less than negative 0.4541. And if I get my calculator and take that probability, second distribution, we're looking for TCDF, negative to negative 0.4541. Degrees of freedom in this case will be 5, right, and minus 2. And tell me what that is. So I don't know if you know what that means. Oh, I didn't multiply it by 2 times 2. So there is a 66.8% chance of that happening. What does that mean? Fail to reject. Null hypothesis. What does that mean? That means there appears to be no correlation. There appears to be no linear correlation, or no correlation would be okay in this case, between fat and sodium content, and specifically burgers. Okay, well, now let's see how this is gonna work. Oh, you know what? That's the conclusion. Now, I forgot to do this. If we do the statistics, I have the table. It's right there. I want n equal 7. So if I copy n equals 7, right there. We want the 5%, so we only want that number. So hopefully by now you're comfortable with that part. There it is. There's n, and there's alpha equals 0.05. So the cutoff is 0.754 and negative 0.754. Remember, that means there's no correlation. There is a strong positive correlation, strong negative correlation, but 0.45 is in there, so there's no correlation. Now, what does that mean? Well, that means, what is the regression equation? The regression equation is y equal, let's see, it's right there, just copy, put the a in there, 930 plus bx plus b plus 6.08 plus 6.08x. There it is. Is it helpful in this situation? No. It is not helpful. Why? Because there is no correlation. If there's no correlation, predict the sodium level of a burger with 25 grams. It doesn't matter what the question is. Our predictor is going to be the average of the y's. So we're going to go to our calculator and we're going to go to stat, and we want to calculate one variable. We don't want L1, we want L2. Let me see how to do that. And we get that by going second. You see there's L1, L2, L3 right there. So you press second, so you clear that, and you press second. You want the Y, L2. And it's going to tell us we just want the average, right? Even though it says X, we know it's not X. So here, if you go second, L2, and L2 is really number 2. You will able to get this part, and remember, this is all we don't want the rest. That's all we want. By the way, you could do all your test statistics on this as well, but we're just trying to minimize it so it doesn't become a big burden on you learning the technology. We're trying to minimize as much as we can. So the average is 1,138.6 milligrams. Or you could say, if you want 1,139, that's okay. So we use the average for any of those. And that's pretty much it. Why are you doing that? Because there is no linear correlation.